Welcome to the video lecture series on formal languages and automata theory. In today's video lecture, we'll be learning about the concepts behind Turing machine. And this is Dr. K. N. Sivabalan. So this lecture will be an introductory lecture connected with Turing machine. So in this lecture, we'll be learning about what is meant by Turing machine, what is the role of Turing machine in recognizing a language. And apart from that, we'll be learning about the formal definition of Turing machine and the functionality of the Turing machine. We'll be learning about all these concepts in this lecture. So without wasting time, we'll be stepping inside the lecture. In general, what is meant by a Turing machine? So Turing machine is called as an abstract simulation of a digital computer, or otherwise it's called as an abstract machine of a digital computer. In a nutshell, we can say that it actually explains how a digital computer functions. In other sense, Turing machine can also use to explore the limitations in computation. For instance, if you have a certain drawbacks in computation, that drawbacks can be identified, and to what extent we can go with Turing machine, that can be used in identifying the computation here. And it is also used to understand the foundations of computer science. Now, when the things are connected with the Turing machine, we can say that the language which is accepted by Turing machine is called as recursive enumerable languages. In some cases, even recursive language is also accepted by Turing machine. A Turing machine have a infinite tape for feeding the inputs inside it. For instance, when you have a string is actually composed of a set of input symbols. On all these input symbols in a form of string will be fed inside this input tape, where further processing will be done by the control system of a Turing machine. Now, since this is an infinite tape, we have to identify where the string starts and where the string ends. For that purpose, we will be using blank symbols, which is used to flank the string. For instance, a blank symbol will be accommodating in the front of the string as well as in the back of the string. So, in between these blank spaces, you can see that there is a string. So, in other sense, this delimiter, blank symbols is also called as delimiter. Now, in short, when we talk about the operations of Turing machine, there are three major operations connected with Turing machine. The first is you will be reading one symbol at a time. That is part of the input. Now, as soon as when you read one symbol at a time, it is supposed to get replaced by another symbol. Maybe you might be replacing it by another symbol, or you will be replacing with the same symbol itself. That is the second stage. Otherwise, it is called as updating the symbol. And the third step, we will be either moving the head in the left or right direction. So, Turing machine has the capability to move the head in both the directions, in contrast to finite state machine or PDA, which has the head movement in only one direction. And this finite control is an element which is used to describe what it has to do with the input. A finite control is a concept which is attached to Turing machine. It will actually explain or determine what you have to do with the output, whether our input has to be processed or input has to be replaced, or whether the string is getting accepted or not. All this has been determined by this finite control. In other sense, finite control is also called as deterministic. Obviously, we'll have only one movement for a specific input, that is called as deterministic. Now, this diagrammatical representation I have shown here is the input tape. Now you can see that there are three symbols inside that. We have a string called as 0, 1, 1. Now these three strings, this inputs has been fed inside the input tape. Now we can see that blank symbols on the left and right side of the input string. Now what happens is this part is called as a input string. Now the next stage is, now this entire finite tape, this entire input tape is called as infinite tape, isn't it? So we will just scan this input tape. Now see here, this entire tape is called as an infinite tape. Now you can see here that this is an infinite tape. because it can accommodate any number of inputs. That's why Turing machine is much powerful compared to other mathematical models. Now this finite control, and the top of the finite control is called as a read head. That means this portion is called as read head. This portion is called as a read head now. Now as soon as you read the input, either you will be replacing with another symbol, or you will be replacing by the same symbol and move the head in either left or right direction. So here one is called as an input. Now we are reading that input. Now read head actually reads this input at a time. Now as soon as you read it, now this 1 is getting replaced by y, and you can see that these blank symbols are actually used to identify the string starting and ending point. It is called as a delimiter. Now as soon as you replace this 1 by y, you keep on moving to the right side. That means finite, this head can move either in the left side or right side. Now in this case I am actually moving on the right side. Now I encounter an input symbol called as 1. When I see 1, now either I will be replacing 1 by 1 itself, or 1 can be replaced by another symbol. So in this case I am replacing 1 by 1 itself. Now what happens here is, in the right side also you have blank symbols here. Now I will be moving on the left direction. So this is how this Turing machine is getting operated here. Now when I go to the next step, Turing machine have certain operations here. The finite control is actually similar to a finite state machine control to some extent. That means it is not exactly similar. In some cases it will be similar with small variations. Now in the second stage, Turing machine has one initial state, but Turing machine has more than one final state. Now these final states are fixed. That means one final state is called as an accepting state, another final state is called as rejecting state. Now the next step is just, as far as the computation of Turing machine is concerned, there are three possibilities. Now generally either will be accepting or rejecting, but here you have an additional possibility. Now the first case is, when the string is a valid string, the Turing machine will accept and halt. If the string is an invalid one, the Turing machine will reject and halt. In case if the string is actually not determined, in that case, some cases it will be the machine might be entering inside an infinite state. When it enters an infinite state, that means the string cannot be determined. In that case, this Turing machine will enter inside a loop. That means it is called as an undecidable state. That means either it is not accepted nor it is rejected. That case is called as undecidable state. Now this is called as a formal definition of a Turing machine. So formal definition of the Turing machine consists of 7 major tuples: Q, sigma, tau, delta, Q0, B and F. Now this Q is called a set of states, sigma is called as finite set of inputs, and this tau is called as finite set of tape symbols. Now the transition function is called as delta. Delta can be given as, say for example in this case, Q, when Q is called as any state, and this sigma is called as any input. That means when any input is applied on any state, now you will get an output called as any state Q, and that input symbol sigma will be replaced by tau. That means it will be replaced by tape symbol, and the last stage is you will be moving the head either in the left or right direction. That's why it has been mentioned as R bar L. R is meant for right and L is meant for left. Now Q0 is called as an initial state, and we have F is called as set of final states. Obviously we have learned that we have one accepting state and one rejecting state. There will be more than one final states here. So that's about Turing machine. Thanks for watching the video. Have a good day.